Good morning, dear students. I welcome you all for the course of refrigeration and air conditioning. And today we will study the load estimation, that is your unit number 6. The primary requirement of cooling or heating equipment is that these must be able to remove or add the heat at the required rate and maintain the comfort conditions in the room. From unit number 4 and unit number 5, we can conclude this 3 lines. Okay, that you may use any air conditioning system, that may be for cooling or that may be for heating. Their final objective is to maintain the comfort conditions inside the room. That could be your summer or that could be of your winter. That could be for your comfort air conditioning, room air conditioning, or that could be for your industrial air conditioning also. Any air conditioning system when you are dealing with, that has to maintain the comfort conditions inside the room. Okay. In unit number 4 also we have studied the properties of air in terms of psychrometry, different processes we have studied. In unit number 5 we have gone for the different types of air conditioning system, different components of air conditioning system. That could have the window AC, that could have split AC or centralized AC or unitary or package system. Okay, so whichever the air conditioning system you are using, that is for heating or cooling, it should maintain the comfort conditions. And to maintain that comfort conditions, you need to install a proper air conditioning unit in that. Correct. If I'm having in big hall or big spaces like cinema theater or a big offices, okay, or multiplex, in that case, in order to cool those particular spaces, in order to air condition those spaces, I can go for the window AC or I can go for the multiple unitary systems over there. Okay, obviously they will not give you the comfort conditions, and even if they are approximately giving you some required temperature or humidity, but the cost of that system, it will be highest one. So to particular space which you want to air condition, there is a particular suitable type of air conditioning system, and that is decided by your load estimations. See, the purpose of load estimation is to determine the size of air conditioning system in order to maintain the inside design comfort conditions. Correct? Your window AC is not suitable for large spaces. Okay, and for just cooling a particular room, you can't go for the centralized air conditioning system. For proper application, there is a proper system provided. Okay. And before selecting any air conditioning system for any application, that could be your comfort air conditioning, that may be for your room, your houses, or that could be for your industrial purposes. But before selecting any air conditioning system, the load estimation has to be done, because your load estimation will only decide that which capacities is suitable for that particular application. According to that particular capacity, according to that particular load, you will going to decide that which air conditioner is suitable for your application. And this is the most important, as I said, if the load estimation is not done properly, this is the essential step. See, whenever you are going for purchasing or for installing any air conditioning system, before that the HVAC engineer or design engineer, he used to go for the load estimation, because this enables him, this ensures him that which system he need to purchase, which system he need to install. And if this load estimation is not done correctly, if it is wrong, then the wrong air conditioning unit or improper appropriate air conditioning system you will be going to install there. And if you will do this, it will not give you the desired comfort conditions. That's why the load estimation has to be done correctly. Many factors are there which are considered when you are going for load estimation. We'll see them. The load estimation involves the following factors. The first one is the magnitude and direction of wind velocity. The space where you are going to install that particular air conditioning system, you need to know the direction of airflow and the magnitude of air velocity. You need to know the maximum values. For a period of a time, you need to monitor the quality of air, its direction, velocity. Okay, you may go for summers, you may go for winters, you may go for different time zones. So multiple values you will have to take it in a table, and accordingly you will have to decide an optimum values. Outside temperature and humidity, again I'm going for summer air conditioning. Okay, I may go for winter air conditioning. So summer I must go for March, April, May. This 3 months I need to observe the different temperatures, different peak values of temperatures and the relative humidity. Same thing I can do it for the winters also. Okay, that November, December and January I must tabulate number of values of temperature and humidity, and accordingly I'm going to design that particular air conditioning system. Along with that, the nature of construction and building material use. This is the important term, because there is also one concept about the building material, that is flywheel concept is there. Okay, flywheel of building material. This is not included in your syllabus, just generalized way I'm telling you that whatever the building material you're having, that material is having its own energy storage capacity. Correct? That whatever the solar radiation or sun rays they're falling on that particular building walls or ceilings or roofs, okay, this material they're not directly transmitting that heat from outside to inside air. Okay, first they are going to absorb that particular heat. It works as like your flywheel that you use in your engine. What it does, it stores the energy when the energy is more, when there excess energy is produced, and whenever the energy requirement is there, and if you are not able to produce it, what you will do, you will use the energy which is stored in that flywheel. Same thing will happen here. Okay, that solar radiation or sun rays which are falling on your building walls, okay, the material will absorb that heat, it will hold that heat up to a certain period of time, up to a time when the outside temperature is slowly reduced. When the outside temperature is slightly reduced, these materials which have stored some heat, they have released that heat in the inside portion of your room, because the temperature is quite low inside compared to outside. So that's why it is observed that the outside temperature is highest when we are talking about the time zone of 12 to 1 p.m. Okay, but when the temperature is slightly reduced, okay, this particular wall or that particular ceiling or that roof, it is going to release that heat at 3 o'clock, let me say 2 to 3 or 3 to 4 times. Okay, so that is about the flywheel of your building material. So that is also an important thing, that which material you are using, what is the type of construction you are having. Again, along with the construction, you need to know about the orientations of the different openings. That could be window, that could be doors. Okay, because as we have gone through the magnitude and the direction of wind velocity, as we are knowing about the airflow, its direction, accordingly we'll have to make the orientation of different openings inside the room. Okay, it's not like that the window should be exactly opposite to each other and just parallel to that door. Okay, according to that particular flow of air, you will have to make an arrangement of different openings, that the diagonal arrangement. Okay, so from one corner the air is entering, and from another diagonal corner air is get removed. Again, at the same time, you need to know about the number of occupancy and the period of occupancy, that how much period of the time the people would be sitting in that room and what activities exactly they are performing. Okay, this is also important part, because one particular office, if I'm talking about, where around 10 to 15 people are working, for that particular office with the 10 to 15 people, there's a different air conditioner. But that office you can't convert it into the classroom, because the capacity will different. That office you can't change it into the gym or any sport club, because activity would be different. Maybe number of people would be same, 15% are there in the office, air conditioning system is of different capacity. 15% are there in the gym, capacity is different, because the activity which is performed in the gym is quite different than the activity which is performed in the office room. Okay, so before designing that air conditioning system, these are the parameters, these are the factors you need to study well to select a proper air conditioning system. Okay. Now the purpose along with designing, along with selection, first one is the load profile over D. Okay, whenever you are going for load estimation, what you are finding out, you are finding out different curves, different profiles of the load. That heating load is how much, cooling load is how much there is a heat gain. Okay, that is the initial part of your load estimation. Then the peak load, obviously you are going for peak load in order to evaluate the maximum load to size and select the refrigeration component, refrigeration cycle component. Okay, that VCR cycle, the 4 components what you are having, that may be compressor, condenser, expansion device, or maybe your evaporator or cooling coil or heating coil. So to decide that one, you need to have the peak load condition, the maximum energy which need to be transferred. That may be adding or that may be subtraction. Heat may be added or that may be removed. But to get that peak load is only for getting the optimum size of the equipment. And obviously, according to these parameters, you can go for the constructional cost also. Whatever the HVAC unit you are going to manufacture, its cost can be decided by this particular above 2 parameter, that is load profile and the peak load. And at the same time, you can go for the operational energy analysis. This compares the total energy which is used in the certain period of time. Okay, and accordingly the best one that can be taken out. Now the next thing is about the classification of load. Okay, the load could be now in different ways we can classify on the different basis. Just like as per season, you may have summer load. Okay, so that is a summer cooling load. When you are having the winter load, that is a winter heating load. Again, depending upon the type of heat which you are going to focus, which is under study, that is sensible heat load and the latent heat load. Okay, sensible heat load that deals with your temperature, dBT. Okay, that how much heat is get encountered over there, how much dBT it has changed. And second one is your latent heat load that deals with the moisture, that is WBT. Again, depending upon the position, you can have the outdoor or indoor heat load. That could be external or internal heat load can be termed as, that is how the heat is coming, whether it is from the outer side or from the interior side. Okay, and the important thing which we need to consider in this unit is cooling load and the heating load. Okay, what is cooling load? It is the amount of heat to be removed from the space, okay, in order to bring it at desired condition by air conditioning equipment. Okay, amount of heat that is removed from the space. Whatever the air conditioning system you are having, that system should be capable of removing the required quantity of heat at the required rate, so that the inside temperature, humidity or inside conditions are maintained properly for your comfort. That is obviously used in the summers. And when you are going for heating load, amount of heat that has to be added. Your heating coil, it should be capable, it should be able to add the heat inside the room to maintain the desired conditions. That is cooling load and the heating loads. Now these are the different heat sources. Okay, heat load sources. You can see there, this is a particular room. Okay, inside that room we are having different sources of heat. These are some internal sources and some sources which are coming out from the outer side. Okay, this is the solar radiation. Okay, now this solar radiation, again, it is through the glass of your window. These are the walls. By conduction, some heat is get added from outer surface of the wall to the inside surface of the wall. These are some outer sources, or you can say that the outdoor sources of heat. Along with that, this infiltration, this is the very important part. Infiltration, that is the amount of heat that is leaks inside your room. This comes through different openings, different cracks. Okay, you may have some openings or some cracks through your windows, through your doors. Through that openings, through that crack, some air will be get entered inside your room, and that is going to change the comfort conditions. Okay, so these are coming from the outer side. This conductive heat gain, it is not only from the wall, but also it is from the floor and from the ceilings. And next is about your internal sources. Now internal sources, that could be, first one is the occupant, that how much amount of heat that particular occupancy is going to get liberate. Again, I have just shown the computer or some equipment, but there are a number of appliances you will have at your houses, you will have in a certain spaces, which are continuously releasing some heat, some sort of heat, some temperature is get increased than the your room temperatures. Then the electric lightings, you will have different motors, some certain lights, or certain you can have machineries, refrigerators, which are again are few sources for your heat. Now we'll go for the cooling load estimation. Now cooling load estimation we will have in two different ways. One is a room load, which exactly falls on your room directly, or it could be a grand total load, which falls on your air conditioning apparatus, which deals with the air conditioning equipment. Room load, that deals with your room and different sources of heat, and grand is nothing but your load that acts on your air conditioning apparatus. Now room load, that could be of sensible heat. First one, sensible heat gain. Now these are the sources. Now the question can come on this cooling load estimation in a way that what are the components of cooling load estimation, okay, or what are the things which we are going to consider when we are dealing with the cooling load calculations. So that time you will have to mention these things. So for room load, we will have two types of heat. One is a sensible heat and one is a latent heat. So sensible heat, it comes through this particular thing. First, that is a solar heat, okay, or the heat which is flowing through the walls, ceiling, floors and roofs, or etc. That is by the conduction media. Okay, from outer side, from solar rays, there is a radiation which is going to increase the temperature of wall, ceilings, floor and roof, and through that, by conduction, it enters to your room. Again, the solar heat, by means of radiation, it can directly passes through the glass of windows or different ventilations. Then again, you may have a partition wall, permissible wall. You may have that a condition that your one room is air conditioned room, okay, but attached to that room, the another room is not air conditioned, okay, so the heat may flow from that also, from those partition wall. In one room there is AC and another room there is no any air conditioning, so heat may flow from that side also. Again, occupancy, the number of occupants, the lights, appliances, they are also internal heat gain sources. Infiltration, the air may leaks through certain cracks or different openings. Again, you will have this if you are using a centralized air conditioning system, okay, when you are having a duct arrangement, so through the ducts also there is a heat transfer inside that room, because inside the duct there is a cool air, but outside the duct, which is open to the atmosphere, open to that particular building passages, they will carry certain heat, and when they'll enter to your air distribution unit inside the room, they may again carry some more heat with it. And if duct is leakage, again more outside air will enter in that particular duct, and it can finally enter to your room. So ultimately the room sensible heat would be changed. Now second is the latent heat. Latent heat, it deals with your moisture, okay, the moisture the water vapor present in the room that can be changed, that can be get increased. First one, it is due to the moisture in infiltration. Whatever the air which leaks inside that room, whatever the air which is entering to your room through those cracks or micro cracks or some openings, they will entered along with some water vapor present in it, some moisture present in it. Okay, so ultimately the latent heat is get somewhat increased. Depending upon number of occupancy, number of occupant in that room, the condensation of moisture will also increase, and that will further deal with the latent heat gain. Again, it might be possible that inside the room certain activity is going on, certain processes are going on. So through these processes, there might be a possibility that some condensation of moisture will take place. For example, simply you will have a cooking process where the moisture is more. So that's also one source of heat gain, latent heat gain. Again, through partition wall, permissible wall, where in the one side of your room there is a high vapor pressure, high water vapor pressure, and moisture would be directly passing through that permissible wall in your air conditioned room. Okay, so these are the few sources of your cooling load estimation, that is room load. That could be sensible heat, that could be latent heat. Now next is the grand total heat, and in grand total heat we are directly having effective room sensible heat. Whatever the factors in sensible heat gain we have considered, we are going to take the effect of them all together in the effective room sensible heat. Okay, and sensible heat of outside air that is not bypassed. Okay, there is a concept of bypass factor also. Okay, some air will be flowing over the coil, some air is get bypassed. Okay, it is assumed that it is desired that whole air is passing over the coil, that may be heating or cooling, and that is get entered to your conditioned space. Okay, so there is also a possibility that there is some air that is get bypassed. Okay, there is also chances of return duct heat gain or return duct leakage gain. Then the latent heat, same thing we are going to discuss again, but in terms of latent heat, in terms of water vapor. And sum of these two, that is your room load and your grand total load, we can have this grand total heat, that is sensible heat, total sensible heat, and total latent heat, that is TSH and TLH, that is grand total heat. And this way you can again understand this particular heat gain, that is external and internal heat gain. You will have this external heat gain, this is your internal heat gain, and this is your conditioned space. This much amount of heat, whatever the sources you are observing, that was of transmission, solar radiation, air ventilation, then lighting, equipment, and people, they all are the heat sources. And this total heat sources, which are of sensible and latent type, they are going to give you the cooling load that has to be act on your air conditioning system. So this is about your cooling load estimation. After this, in next part, we will discuss the numericals associated with the load estimation, because when you will solve the numerical, few more parameter will come into the picture and you will understand it very well on psychrometric chart. Already the notes, the PDF notes of this unit number 6 I have provided to you. You can refer that also. And meanwhile, we will solve few numericals on load estimation in this way only. Okay, thank you.